Hello and welcome. Today we are looking at something called refractive index, but before we can work out what this is and how we calculate it and what it means, I just want to do a quick recap on what we mean by another word, and that other word is refraction. And this is something we've come across before, so you should be fairly familiar with it, but let's just do a quick recap. Now, refraction is described as the changing of direction of light when it goes from one medium to another. So when light travels from one medium, say air, into water, the light will change direction. Very important that you make sure you line these up properly. So the light changes direction and we call that refraction. Also important to put an arrow on the light ray so you know which way the light ray is going in. But this idea here is the idea of refraction. We can do a similar thing from air into glass. So if we've got some a glass prism here, we've got a light ray hitting the glass prism, and again it will change direction. In other words, we will get refraction. So this is the key idea of what we mean by refraction, and we can use it to work out this thing called a refractive index. And the refractive index is a feature of specific materials. So imagine we've got glass here, and it's a feature of specific materials related to how the light rays would refract when they go into this medium. Okay, so again, before we do that, let's have a look at this diagram here. We've got another line which we haven't recapped on yet, but this line here, you may remember, it's called the normal line, and it's an imaginary line that's at 90 degrees to the surface that we are looking at. This needs an arrow. Okay, so that's the normal line, and another label that you need to know is called I, and that just stands for angle of incidence. That's the angle at which the light ray hits the glass prism compared to the normal line. The other value that you need to know is called R, and that's called the angle of refraction. So it's the angle of, being lazy there, angle of refraction. And we can use these two values to calculate this quantity called the refractive index. And to work out the refractive index, we need a formula that looks like this. Refractive index is sine I over sine R. Now sine here is a mathematical term. It's actually written as SINE, abbreviated to SIN and pronounced sine, and it's the sine of this angle here divided by the sine of this angle here. So for example, if this angle was 45 degrees, if you clicked sine or press sine on your calculator, you'd get a value of 0.707, I believe. On your calculator it might look a bit like this, but that's how we work it out. So if we can work out the sine of our angle of incidence divided by the sine of our angle of refraction, we can calculate the refractive index of this particular material. For any angle that we have as an angle of incidence, if we divide it by the angle of refraction, we should get for our material the same value every time. So let's give that a go. Here's our formula. Refractive index is sine I over sine R, and if we work the first one out together, then you can have a go at these two by yourselves and see what you come up with. But for one example here, for our glass prism, we've got an angle of incidence here of 10 degrees and an angle of refraction of 6.5. So let's work out sine I first. For sine 10 degrees, if you type in 10 and then click sine on your calculator, or on some calculators you have to press sine first, but either way you should get a value of 0.174. You actually get quite a long number, but I've just condensed it to 3 decimal places. So for sine I it's 0.174, and for sine R 6.5, the sine of that is 0.113. And then if we use our formula to calculate the refractive index, sine I over sine R, the answer you get should be 1.54. So the refractive index for this material is 1.54. If we do the same again for these pairs of values, we should get values that are close to the refractive index of our first set of readings here. So it's probably worth pausing here, having a go at those just as a bit of practice, so you understand how to use sine and to use the formula and see what numbers you come up with. So you can pause now, give it a go, and then have a look at the answers in a sec. Okay, so for the second example, these are the sets of values that you should get. 0.342, 0.216, and you should get a refractive index of 1.58. Next set of values are as follows, and as you can see, we're getting values that are close to each other. We're not getting the exact same values because you can imagine that here I've measured 6.5 degrees. If I was out by half a degree there on my protractor, I would get a slightly different value of sine r. So they're not always the same, but if we work out the mean, and that's just adding them up and dividing by 3, we get a value that's rounded up to 1.56. So the refractive index for this material, this glass, is 1.56. It's probably worth just having a look at some values for some different materials. We can have water, oil, glass and diamond, and these are the refractive indexes of these materials. So diamond's got quite a high one, 2.42, glass is 1.52, water 1.33, oil 1.51. okay, so they don't have values because they are ratios, and these are the kinds of figures that we look at when we're talking about refractive indexes, and you should be able to work out the refractive index of a material given the values that we've just talked about in this video.